Dean of NBS, CEO of Intuit, fellow friends of the NBS, and also I believe a lot of you are from the EMBA program. A real privilege to be back in the business school and sitting here, and really exciting to hear lots of ideas coming out from the university, and I must congratulate NTU for reaching the top 30s in the world ranking in the recent QS. So really makes me very proud to be part of this. I hope to perhaps move from IT, where you move at the speed of light, and then to something much slower and calmer, which is the speed of flowing of water. The main thrust of my talk at the invitation of the Dean is to just share with you what we're trying to do, and also to perhaps seek some ideas and constructive criticisms on how we can do things better. I will just talk a bit about the innovation landscape in the water membrane space, and a little bit on the Nano Sun technology. Most importantly, perhaps of greater interest to you, is the commercialization process that we're going through, to the extent that we can bring an idea to the market. So the idea to the market and how long you take. To me, that is probably the most exciting idea that I can share with you this morning. And I hope to talk a lot more about that and some projects as we show. When we try to think of the disruption that we can have in any field, not least, I often think of my friend Gunther Dufay, who's sitting up there. Oops. The McKinsey guru of our business school. Really, we're looking at the advances that transform life, business, and the global economy. I spent some time in McKinsey, and these guys are constantly looking for the best ideas, and they have the advantage of being able to work with many, many companies. And in the Global Institute, they have this vast database, and in 24 hours, any question can be answered. For instance, for things like pricing. If I had a problem on pricing, I just put it out on the net, and within hours, friends from Barcelona will say, hey, this is the latest Dutch auction modified, version 4.0. So that database is, in my mind, one of the most important things that we can use. And I'm going to focus on the disruptive part of the business. Just very quickly to introduce you into the membrane space, the fundamental principle is to move and to remove particles from large to small. So globally, every drop of water that you drink, to the extent that it's treated, you go from big to small. So the smallest would be the atomic particles, and then that's in the reverse osmosis space. We're not in that. That's a very capital-intensive space. And the larger ones are like screens. And in between, there is this ultrafiltration and microfiltration. Now, when we talk about nano distances, the best example I can ever think of is that from Richard Feynman, the nuclear physicist. A nanometer, if you were to put in your mind the distance from the Earth to the Moon, and that's 1 meter, a nanometer is the distance from the bottom of your chin and the top of your head. That is 1 nanometer. The AIDS virus is 35 nanometers. The polio virus is 17 nanometers. A bacteria that gives you stomachache, E. coli for instance, is 2,000 nanometers. So we live in the nanometer space, if you like. How many nanometers? And industry from all over the world is trying to control this space. Whoever can get to filtration at the cheapest price, at the lowest cost of production, will win. So for me, I look at commercial realities and the innovation drive. The creative tensions that come as a result of the competitive forces. So how will the game change? Every time there's an innovation, there is a disruption. Every time there's a regulatory change, there's an opportunity for the application of the disruption. So game changing. We expect surprises. It is not a steady state world where things are moving all the time. Principles are useful in the classroom, but the discontinuity is what we're looking for. So expect surprises. the market is changing. People want better lives, good life as I read it, higher quality. So you find that people are going to spend a lot more money. Now some of you hold a bottle of water in your hand, right? To do that, you can sell that for $2,000 a ton. It costs us between $15 to $30 to treat it. 90% of the money goes into the bottle. So we are in a different kind of world where we look at water and we treat it, but globally we are going to be faced with a lot of shortage. And so that's where the market changes. It's going to be very interesting. Now we have this old and new because municipals are very conservative, but yet they're trying to get things done cheaper, better, and faster. If you go to Saudi Arabia, 60% of the water comes from boiling the ocean, 40% from reverse osmosis. Well, they can do that, right? Because they've got oil, right? Just get some barrels and boil something. If you like a cup of tea. So, but for most of us, we can't afford to do that. So we need to find better ideas. So therein lies the demand. Creative tensions come as a result of demand. I'm going to show you a little bit of how demand translates to how it impacts our business. The market is huge. It's a $360 billion market globally. But pertinent to us is how do we use material science and material strength, and then how do we penetrate the market from using what we are very good at, which is industrial treatment water. The growth rates historically, as you can see, from 1990 to 2015, we're looking at a lot of billions of dollars, right? So just capturing a slice of it. So let's just do a mathematical exercise. You have here probably about, say, $2 billion going forward. If you take 10% share, then you're looking at $200 million, right? And if you take 1% share, that's 20 million. Okay? If you have, say, 30% margin, that's good money. So you don't have to do a lot, just do a bit. I tried to do this just now coming in, Dean. I was trying to value Nanyang Business School, or Nanyang NTU itself. So here are my numbers, right? You've got about 20,000 students, each paying about $15,000. So you get about $300 million of revenue. And if you get 30%, say, profit margins, give it a 20 times multiple because you're a good brand name, top school. NTU is worth $4.5 billion as we speak. The same. We're doing the same with the water space. And that's where the money is. Membranes are being used worldwide. You can see that in this very short span of time, estimates are giving it, almost a 50% uplift in estimates in a very specialized part called the low pressure membranes. So the question is, this space is absolutely vast. Finding the right place where you can win is really, to my mind, the whole trick. The Nanyang Business School and the engineering school, we got together. I'm from the industry. I'm really not an academic per se. My academic career ended at my undergraduate, and that was the end of it. The idea is really how do you get somebody with the intellectual capital, and then I came from banking and liquidity, so he deals with liquids, my other founder, Darren, and he started in '97. So in '06 we got some money from the Prime Minister's office for $1 million, and then we used that to launch into a program and raise another $1 million to match. So back in '06, if you use the time value of money, it's about $4 today, $4 million if you like. Won some awards, got some patents and all that. But by the way, patents are somewhat of a, I would say, a mirage, because if you don't use them after 3 years, it's quite worthless. So the question is, how do you get from ideas to market? That's really what we're trying to do. So we raised some more money, $2, and then we went for valuation. It's more than $5. That's a pre-product. Now we've got a product. We are revaluing this up a little bit more. Some investment banks, my old friends out there in the street, saying that we can launch it between 80 to 120. My friends in the Silicon Valley say that, it's too low, should ratchet a bit more. So, but we're not the valley. The valley where Lindri came from is a lot more intense, very aggressive. This is water, so we moved to a different valuation metric. So the central thesis is, how do you take an idea and bring it to market? If you forget everything else, it's just take an idea, bring it to market. That's really my sharing with you. We were invited by the technical advisor to the US State Department, a certain Dr. William Coglesier, and he's now advising Secretary Kerry. And we went up there. We have a talk on nanotechnology. The US government spent billions of dollars, and they looked for us and said, come, tell us how do you do what you do, because we can help you take your idea to the market. So we're out there in the Marshall Hall. We spoke. The founder is over here, Darren, from the engineering school. Person on the next to him is a certain Mark Grotmeyer. Mark is a lawyer, and he had a colleague called Hillary Clinton in the same law firm. He raised money and said, can I help your husband and become a governor? And then raised some more money, can I help you be a president? So Mark is now running the Global Technology Exploitation and Deployment Initiative. And where he is where the Walmart, the Sam Walton's family, every one of them is worth $26 billion or more. And he said to us, we can help you move certain things, if you don't mind. I said, yeah, sure, why not? And Mark is now interested in technology exploitation and deployment. Not so much the fundamental science of the ideas. His for-profit organization is to help take that business out into the market space. So now we have a standing offer to provide some of our water solutions to Rwanda, because one of the founders pumped in $100 million to build infrastructure in Rwanda. And basically, propping up the whole economy, giving schools, medical services. Gentleman next to him is Alfred Watkins. He worked for a very small Jewish company. So did I. It's called Lehman Brothers. So that's the story. But anyway, so Darren got shortlisted and was nominated as a professor for water, the Shimizu professor at Stanford. So he's out the West Coast. But frankly, guys like us on the East Coast don't look at the West Coast too seriously, because they rear cows there in the ranch. So we are much more on the East Coast side. So between us, we cover the whole spectrum of US technologies. The idea is to now take that and apply it in a market like India or China. So you've got ideas, you've got markets. Had a short press release. I think that was quite kind of them. Let me just move on. Oh gosh, it's stuck. Does it work? Mine's a PDF files. I have a PowerPoint. Well, anyway, while waiting, let me just continue talking. So we've got a team. We've got lots of people with a lot of hands-on experience. What I try to do is to bring in people who can build the parts and components and to commercialize it. So my idea is to head out to various places. So I'm talking to people in India to build certain components. I'm talking to China, and they're helping us to accelerate that process. Okay? So really that's what I'm trying to do. We recently got a deal from a French oil major called Elf Total. They are worth $108 billion. So from my point of view, it's a very good reference customer. Our first deal is going to be delivered. I'm shipping them out 12 October, this next month. We should be ready and commissioned by about December. We've got other deals going on in Indonesia, so an emerging market is interesting. And then on the other side, we've got... Should I pick up one? Okay. I hope you don't mind. Okay. Okay, I'm just... Okay. Yeah, thank you. Sorry about that, but basically, taking an idea to the market, that's my whole thesis. E. coli, lots of water in the equatorial area. You've got bacteria that's killing people. We just had 2 kids being killed out in Wisconsin last week, reported by Bloomberg. We can remove this in minutes if you could look at the red line. That's what we do. And then going to industrial side, we look into hours. The red line is our performance, meaning to say the pressure that we need to put the same amount of water across is the same. Whereas if the membrane gets stuck and gets clogged up, you need to put more and more pressure to push the water. So in the absence of our technology, you'll be using the blue line. We're spending a lot of energy to push water across. So what we then do is to apply nanoscience and apply it at the surface of the membrane. So quite simply, this is what we do. The raison d'etre for our existence is to remove that. You can see that for water that you drink every day, before it reaches you, the membranes look like that in the top left corner. Now, if the membrane breaks, then all that stuff goes into the water. So the question is, how do you build a membrane that's reliable? I mean, we read about the carbon nanotubes costing like $10 for a gram. That's really expensive stuff. Very strong, very lightweight. We're trying to do this using slightly different materials. Our process, we have a very simple 4-step process. We develop the products. I left engineering for a long time. You know, my career in academic left. But we've got a whole team of people working. We're now producing. We started with a membrane no larger than a credit card size. We're now producing hundreds of meters, which then can be put into modules and then can be shipped out. The methods include very advanced 3D printing to very basic hot pressing, you know, just good stuff. This is our unit. The deployable water unit is very interesting, both from a market's point of view, because we deploy the system with the client. We say to them, you can have it for free. And they say, why not? I said, well, you can have it for free for as long as you want. And he said, why not? But my condition is you collect data for me. So I have online data that comes back into my database, and I know what the performance of the water is like at the output. And the input we also know. And when we get into that and we try to solve it, we then find what in physics we call an eigenvalue, a steady state number. And that determines the size of the plant for 30,000. So this is a pre-sales model that we use. We get close to the customer. How do you get close? Really close. We put it where they are. And when they're done with it, they say, can we move this to another place? I said, sure. But by then we would have gotten into the entire architecture, the decision-making process, the IT department, the chemicals department, the control department, the finance department, and all that information comes into us. No different from how we do analytics in the credit cards in the bank. And then to give some credibility, we then apply ISO 9000 standards, really with the view of the top right-hand corner, the black box, with the view of exporting. Singapore has to be an export-oriented country going forward because services are very transient. They migrate like nobody's business. In 4 hours, I can move $4 billion out of a bank. We've done that in the IPO space. That's what we do. So manufacturing, innovation, lots of entrepreneurship, the sort of stuff that Dr. Lim Joy is doing. I would really respect that because that's when you start. Some of the large state-owned enterprises in China, they have products. They're starting to go into real economies. So for me, an ex-financier, I find this quite interesting. Going forward, I will buy water plants by way of acquisition. I have a whole team of diligence people who do that very well. I've got expertise in engineering. So you combine finance and engineering, plus a localization factor. And when I can make that plant profitable, now when a plant's not profitable, I'll buy it for $1. When I make it profitable, I can't sell at $1. Maybe $15 million, maybe 40, maybe 50. I put that in the business trust. I can securitize the cash flows. Then I buy some more plants. So going forward, we will use technology to insert and get closer to clients. And then the plants that we buy, I can put in new technologies. Then I have technology insertion. So I guess, you're in the business school, you may be learning about S-curves and so on. We're very open to new S-curves, new disruptions. This is our deal flow. For confidentiality, I can't disclose them, but Indonesian market, we're moving very quickly. The last one, the client at the bottom is a listed company. They are like 7.7 Hong Kong dollars on the market cap. That's like 1.3, 1.4 billion dollars. They want us to do something for them. How do we do it? This is what we do. We use the database that we have for industrial scale. And then we have the material science, and we take the idea to the market. So always getting closer and closer to the market, to the client. All these rivers are red, blue, green. So if a cat walks across the river, you see the yellow cat, it's yellow. And the dog goes the other side, it becomes green, they're printing. So in India, it costs $5 to treat a ton of this kind of water. I can do it for 80 cents. And in return, we give back green spaces. So that's the impact of using the ideas to the market. A couple of quick slides. This is what we do, getting closer to the market. The exam question, reduce the color. You can do that. We retrofit. We have commercial structures. We talk to bankers, old friends. We raise money. We do numbers. We promise 42%, but we've got to make at least 60, right, just in case I miss targets. So the IRR of 42% on exit, and on very conservative multiples of 10 times. So myself, having come from the investment banking world, we definitely will not sell at 10 times. The Credit Suisse papers are looking at 28 times on a very good one. We haven't got scale. Maybe we'll hit it at 20 times. So all we need to do right now is just have perhaps net profits of say 10 million, multiples of 20. I think that's not too bad, right? Okay, so with that, thank you very much.